Sinusoidal functions. In our previous lesson, we talked about how we can map over an XY coordinate the movement of the circle, moving around the circle. And there are certain measurements we can do. And as I said before, we usually start from the beginning and then it repeats itself once it goes all the way around the circle. Before going farther, there's some terms I want to discuss. The midline. The midline is a horizontal line that goes exactly through the middle between the uppermost part and the lowermost part of our sine wave or cosine wave. There's an equal distance here as there is to the bottommost part right here. And then there's the amplitude. That is the distance from the midpoint to the highest point or the lowest point. There's absolute value. Then the period is the distance from where it starts at whatever position it is to where it repeats that position again. Now, here is a sine wave. And let's take a look at what we can find if we find our midline, our amplitude, and our frequency. The midline is simply you add the highest and the lowest and then divide by 2. It's basically finding the mean. And my lowest point, no matter where I go here, my highest point is 7. There's 7, there's 7 again, and it goes up here through 7. My lowest is 3. Right, there's 3 right there, and there's 3 right there. 7 plus 3 is 10, which is right here, and I divide by 2, which gives me a midline of y equals 5. And you can see here is 5 right here, and this cuts pretty, I'm not sure I'm going to make a straight line on this, but it cuts right through there. Half are above, half are below. The amplitude, remember, that's the distance from the midline to either the highest point or the lowest point. The highest point is 7. My midline is 5. 7 minus 5 is 2. I can also go from this direction, and it's an absolute. Here's 5, here's 3, and it's 3 minus 5, but it is an absolute. 3 minus 5 equals negative 2, but as I said, it's an absolute distance, so that equals 2. You go either direction. And then the period is how long it takes until it starts back over. And most of the time, when we look at sine waves, cosine waves, tangent waves, we don't have numeric values on the bottom. We have radians. As you can see here, pi of 4, pi over 2, 3 pi over 4, there's pi, and then there's 2 pi. So this is the beginning of the circle, this is halfway around, and then this is all the way around where it starts all over. So basically what we're saying here is, how many times does it go up and down to its original point per 2 pi? And that's called a period. Right here, here's 2 pi, one complete circle, and here is, it starts from here, if I go from here, where it start over, right here at pi. And then there's another one, goes all the way up and all the way down, and then back again, where it goes right here at 2 pi. So there's 2 complete oscillations where it goes back to the original position within this sine wave. Let's find the amplitude, the midline, the period of the cosine function this time. Midline is still the highest plus the lowest divided by 2. My highest is 1. My lowest is negative 5. So it'd be negative 5 plus 1, which is negative 4, over 2 equals negative 2. And you can see the midline. It looks, it is right there. It is at negative 2 there. And now I can find my amplitude. My amplitude is that distance from the midline to the highest point or lowest point. And that looks like the highest point over here is 1. My midline is negative 2. That's an absolute distance of 3. And I could go from negative 5 to negative 2 in this direction, and still an absolute distance of 3. Either way, it is 3. Forgive me for my not so straight lines. And then how many times does it go to a complete, its original beginning, to its highest or its lowest point per 2 pi? Well, here's 2 pi right here. And if I start here, there's 1 oscillation. There's 2 oscillations. There's 3 oscillations. And actually, this first one's a half. Then there's another half right here, because this is 2 pi right there. And that's also a half. So it's actually 1, 2, 3, plus these 2 halves, 4. So my frequency is 4. In other words, it peaks or it troughs. The highest point is a peak, the lowest point is a trough. It repeats itself 4 times within 2 pi. Now, just some basic things here. When you look at y equals sine x versus y equals negative sine x, if you look at this, they look very similar, except the sine x versus the negative sine x are reflections of each other. Notice how this one, that starts at 0, is going up, and this one starting at 0, negative sine x, is going down. Another thing I don't want you to be confused by is looking at these waves between a sine wave and a cosine wave. They look very similar, but I want you to notice the difference. This one starts at 0. Let me get my pen going. This one starts at 1. And remember, this is the distance around the circle. And this is either the x-axis for cosine. This is the y-axis for sine. Let's go back to a unit circle. Y starts at 0 and 1. Because when I have a unit circle here, remember my coordinate here at the very beginning, right here, is 1, 0. That's also 0 pi, or 2 pi. So when I start here, remember, this is 0 pi, and here's my 0 pi right here, in this direction. And what is my y coordinate? It's 0. So my sine wave starts right here. On my cosine wave, I still at 0 pi, but my x coordinate is 1. So it starts at 1 right there. And that is the basic difference. Is this a shift between the cosine and the sine when you're looking at the sinusoidal wave. Now we're going to do a little bit more advanced functions. So I want you to notice this. And these aren't hard to do. It's just a matter of interpretation and recognizing what numbers you're looking at. If I got y equals sine x versus y equals cosine x, well, this is y equals sine x on the left here. And if you notice, my amplitude, let me make a pen here, is 1. Over here, where it's y equals 2 sine x, my amplitude is 2. And that is in front of the sine. So that talks about the amplitude, how tall it is. If you don't have anything in front of the sine, it's an amplitude of 1. If it's 2 sine x, 3 sine x, 2 cosine x, 5 sine x, that is the amplitude. Now in this one, I've got y equals sine x versus y equals sine 2x. And when I have the numeric after the sign, 2x here after the sign, or this x after the sign, this tells me how many oscillations there are per 2 pi. Notice most of these are both 2 pi, right from here to here. But there's only one oscillation. It starts here, and it renews itself, starts all over at here. And there's only one complete oscillation here. So that'd be the same as sine of 1x, one oscillation per 2 pi. On this one, y equals sine 2x, there is 1, right here from 0 to pi, and then another one to 2 pi. So there's 2 oscillations per 2 pi. So this is y sine 2x. Same thing, it goes in the reverse order actually here. Sine x versus y equals sine 1/2 x. And what you notice here, y equals sine x, same as before. I've got one, on the left here, I've got one complete oscillation per 2 pi. Right there, starts there. And there's my 2 pi, and it starts all over at 2 pi. So it's just sine 1x. And the second one, I've got sine 1/2 x. Now that's interesting, because if you look, if I draw this out, this is slightly different. Here's 2 pi, here's 4 pi. It only goes half an oscillation per 2 pi. This is only halfway across from here to here. It actually takes 4 pi to go one complete oscillation. So this is a sine of 1/2. On this slide, I'm subtracting a number from the entire sine or cosine, the entire trigonometric equation. On the left here, I got y equals sine x. On the right, I have y equals sine x minus 2. This is no different than a linear equation. And all we're simply doing is this minus 2 right here moves it down. The midpoint is now at minus 2. The midpoint here, y equals sine x, is at 0. Midpoint here is minus 2. All that minus 2 represents on the outside of all that is I have moved it down. Both have an amplitude of 1. You can see there. My midpoint, there's my amplitude of 1. And that minus 2 just means it's minus 2 down. If it was sine x equals plus 2, it would look something like this. That's as I can draw. So that just tells you the location relative to the y-axis. Now, if I give you a sinusoidal function, can I determine the equation for it? Not that difficult. Let's find the midpoint first. My highest point is 6, right here. My lowest point is 0. 6 plus 0 is 6, divided by 2. So my midpoint is 3, and that looks right. Half are above, half are below it. And then what's the distance between 3 and 6, or 3 and 0? It's actually going to be 3. 3 plus 3 is 6, and 0 plus 3 is 3. So my amplitude is 3. Now, if as a sine wave, it normally starts at 0, if you remember. But this went up by 3. If I move it down by 3, it'd be back at the original 0. So we now know it's plus 3. We know the midpoint is at 3, so that sits right there. Now, the other thing we've got to find out is what is the oscillations. Like I said, it starts at 0, so we know it's a sine wave. So we know it's sine right here. It's plus 3. And then here's 2 pi right here. How many complete oscillations does it make? Well, there's 1. There's 2. 1, 2. It starts over twice. So that's going to be 2 oscillations. So it'll be 2x. And then I've got 3 here. The amplitude is 3. So the amplitude is 3. So that's going to be 3 sine 2x, amplitude of 3 times sine 2 oscillations x plus 3. And don't get confused about 2 different 3's. This 3 is what it is above the 0. That's this plus 3. Then the other 3 refers to the amplitude. It's 3 up and down this way, and 3 up and down this way from the median. Now let's look at this one. Can I define what this graph is? Well, let's see. I'm going to tell you one thing right now. It does not do a complete wave to 2 pi. It only does half a wave, in fact. So it takes 4 pi. So it only does half a wave here. I know my inside is going to be 1/2. It will be, and it's starting, let's see here. Where's it starting at? Is it starting? It's starting at, it's not starting at the origin. It's starting at, looks like 2. That's going to make it a cosine. Now, it starts at 2 here. Let's see what my amplitude is. Well, the highest point is 2. First, let's find my midpoint. Sorry. 2 plus -2 is 0. So my midpoint is 0, and that seems to fit. It's right at the x-axis here. So that's my midpoint. And then it's 2 above from the midpoint or 2 below. So my amplitude is 2. So that's going to be 2 in front of it. And really, I didn't move it up or down at all. It's starting at the origin. So it's going to be plus, there should be an x there, plus 0. And you don't have to put plus 0. But this is the equation, y equals 2 cosine 1/2 x plus 0. There's my amplitude. There is where the midpoint is. And this is my oscillations right here.